again, everybody. Welcome to APNIC eLearning web class. Today is Wednesday, the 26th of March in 2014. It is 10:30 in the morning from Brisbane, Australia, where I'm broadcasting this class. Now, this is the first session that we are going to do for today, and the topic that we will cover is all about 4-byte autonomous system numbers. So generally, we will look at autonomous system numbers, what are their uses for, and of course, the focus will be 4-byte ASN. So what's the difference between 4-byte, of course, 4-byte and 2-byte ASNs. Now, a brief introduction of myself. My name is Cheryl Hermoso. I work for APNIC training team, and we do workshops, tutorials on different topics such as IPv6, network security, DNS and DNSSEC, internet resource management, and routing. Now, just a reminder that this class will run for 1 hour. And at the end of the session, I will be asking you to fill in a survey for me, just so I'll have an idea of basically what we can improve on with regards to this type of classes. All right, now as I've mentioned, our focus is on 4-byte AS numbers, but we will have a very brief discussion of AS numbers in general. And from there, we will see the difference between the ranges of 2-byte and 4-byte. Now, I would assume that perhaps you have some idea about 2 bytes. You may have used it before, or you've seen how it works. So we will just basically differentiate the how to represent a 32-bit or a 4-byte AS numbers. What are the additional attributes that we can use now so that 4-byte can work alongside 2-byte AS numbers? So that's the AS path. New AS path attributes. We also have the new aggregate attributes. So all those things, and we will have some examples on how this could work. All right, so that's our plan. Hopefully we'll have enough time. 1 hour is about enough time to cover for this class. All right, so let's begin with just a brief look of AS numbers. You know what an AS number is, right? It's a resource. It's a number resource alongside the others that are more popular, such as IPv4 and IPv6. So it's a number resource. If you need these resources, you have to get them from either your upstream provider or from a registry, an internet registry such as APNIC. So that is if you need the AS numbers to connect, of course, or to give an identity to your networks. So how do networks communicate with each other? The internet itself is composed of different autonomous systems. When we say an autonomous system, it's a unique, basically a unique set of network that belong to the same people or to the same policy, having the same policy, or belongs to the same administrative group. So those are the two things that define an autonomous system. And in order for us to maybe send and receive packets, to send traffic to other networks, there must be a way of communicating with them, right? So we use routing protocols for that. And how do we identify different autonomous systems? We said that they will have their own policies, and therefore, in order for these different networks to communicate with each other, there should be an identity. So we use a number. We use an autonomous system number. For a very long time, we are using a 2-byte ASN. So what do we mean by that? So 2 bytes is, of course, 16 bits. But it is represented in decimal. So you see here, these are our AS numbers. Originally, the range of our AS number would be from 0 to 65535. So those are the first set of ranges. That is the 2-byte or the 16-bit AS number. Okay, if you see BGP routes on your routing table, most of the time, I would say about 80% of the time, you will see an AS path or a list of these networks that needs to be traversed by your routers or by the packet in order to get to a destination, right? If I need to get from A to D. And my routing table says that your possible path will be going from A, jump to B, then to C, going to D, right? That is typical routing information that's given, okay, on your routing table. This is how you get from A to D. So now that lists A, B, C, and D, it's represented in AS numbers. So you see there a list of, let's say, a path of all the AS numbers that needs to jump into. That is what we mean by that. So normally, I said it's about 80% of the time perhaps, you will see that as a number ranging from 0 to 65535. So that is your 2-byte AS numbers. Now we are introducing, well, this has been going on for a while. It started out in around 2009, but we are introducing a new set, or more specifically, I think it's not exactly a new set, but an extension of the original 2-byte AS numbers. Okay, why are we doing this? First of all, if you are aware of the exhaustion in IPv4, so that's a range of IP addresses, right? And we are reaching exhaustion, meaning we are sort of running out of IP addresses and there won't be enough in the future. In the AS number pool, we are somehow experiencing the same thing. Okay, as networks grow, we need more AS numbers to assign to different autonomous systems. And of course, they've seen that we might need to either create a new set of AS numbers or maybe just extend it. So now what we are actually doing is extend these AS numbers to accommodate up to 4.3 billion. Okay, so you've extended from 16 to 32 bits. So your new range now is from 0 to 4 billion, much like the same range of your IPv4 addresses, right? Now, so from that, we have different groups, okay, different ranges that are used for different things. So 0 and 65535 are reserved. They are not used for any publicly available networks. But for the public internet, if you want your autonomous systems to be reachable, to be part of an AS path, then your range should be somewhere from 1 to 64495 in the original 2-byte AS numbers. 64496 and up to 64511 are for documentation purposes, and therefore it's not recommended to use them in any public internet. But there's also a range for private use. So if you want to compare that with IPv4, you have public and private addresses, right? Similarly with AS number, we have something that is used for public domain and something that is used for private domain. Now, for example, you are a network, okay? You're a network, you have an upstream provider, and you want to maybe configure BGP between these two networks, right? But your ISP is your only upstream. You're not doing multi-homing, meaning you don't have 2 or more upstream providers. So actually, you can use a private AS number for that, okay? So you'll use anything from this range, okay, and configure your router. Then your ISP will configure their router to peer with that other network with that AS number. Okay, in that case, that's a privately used AS number because it doesn't have to go beyond the ISP's network. But if it will be passed on, it will be spread out or announced on the global internet, then we might need to stick with this. Anyway, enough of that. The more important part is this, of course. As we've said before, we stopped at 65535, but nowadays, with 4-byte AS number, we are extending that to 4 billion. And so we have added a new documentation range or prefix for a 4-byte, which is 65536 to 65531, and the rest is for public internet. If you notice, there's another set of numbers that is 23456. It's kind of funny looking, but it's a very useful AS number that is for migrating. For if some networks are using 2-byte, some networks are using 4-byte, then this is a way for them to still see or communicate with each other using, even if they're using different sets of AS numbers. We will look more into that as we move on. Now, How do we write down an AS number? With 2 byte, it's easy. It's plainly converting a 16-bit number, okay, a 16-bit binary number into decimal. That's why, as I've said, our range is from 0 to 65535. 65535 is essentially all ones in binary that are converted into decimal. Now, how about with 32 bits? There are two ways. There are two ways in which we can represent that, either using AS dot and the other one is using AS plain. Now, let me explain AS plain first because this one's easier. This is essentially the same as how we represent a 2-byte AS number. So, from a binary number, you translate it into a decimal value. Simple as that. So before, if your range is only up to 65535, nowadays if you have a list or a list of all ones that are 32 bits, if you convert that into decimal, that's essentially 4.3 billion. So your range is from 0 to 4.3 billion, and you write that down. When you do your configuration, you use any of these numbers that are assigned to you. That is AS plain. So basically, it's a straightforward conversion from binary into a single decimal value. Now, going back to AS dot here, now it seems like when you use AS plain, you have a huge number. AS 4 billion, that seems like a very long number for some. So one workaround is to use AS dot. With AS dot, you somehow preserved the numbering system in 16-bit AS numbers. How? Because we will now subdivide our 32 bits into 2 halves. Okay, we have a upper 2 bytes and you have a lower 2 bytes, and then convert each of them separately into decimal. So your maximum value will be all ones that are 32 bits, which is 65535, and then you use a dot to separate them, and then the other half will be another 65535. Okay, so your range will be from 0.0 all the way to 65535.65535. Okay, it looks more it looks better from an administrator that is doing all these configurations. The downside to it is when you have a lot of, let's say, regular expressions. And as you know, dot is a meta character in regex, in regular expressions. And it means something. If you want to set rules, if you want to create filters, okay, you have like set of lines there that somehow may be using the dot character to filter out those prefixes that you are receiving. And so if you are going to use AS dot now, you can't just straightforward copy your configurations from way before and then use 4-byte AS numbers. You will have to look at, okay, how it has affected your filters. So in our region, we are not exactly not allowing, but we are not recommending to use AS dot. The easier way would just be to stick with AS plain. And as you know, AS plain is a simple translation from a 32-bit binary number into its decimal equivalent. Alright? Now, if you're still having, say, some trouble with the conversion is pretty easy. It's pretty straightforward. If you need assistance in doing that, though, like to make things easier, there is a utility, a tool that you can use. One of them is found in the eBNIC website. So you just pretty much type in either the binary value or maybe the AS plain value if you want it to convert to AS dot, and also vice versa. All right. Now let's explain a little about AS path. I have somehow touched on this when I was doing the introduction. I said that we have a lot of autonomous systems. These different networks have a routing table, and the routing table consists of the prefixes that other networks are announcing to him and gives a path or gives an instruction on how to get there. Our example that I gave you was, if I needed to get from A to D, what is my path? If I receive a packet, I will then check with my routing table. Hey, how do I transfer this? What is my next hop? Where do I send this next? Okay, so the routing table consists of a lot of attributes, consists of a lot of information, and one of them is a listing of the path that it needs to traverse to get to that prefix. So going to this example, if you see this diagram here, I have 5 networks, okay, 5 autonomous systems, AS100, 200, 300, 400, and 500. So how does the routing table look like from each of these networks? So let's just say that AS100 is announcing a prefix, it's 180.10/16. AS200 is also announcing a prefix, 170.10/16. Assuming that AS300 is receiving routes from AS100 and AS200, then he can now also forward that information, that routing information, to his other peers. His other directly connected peers are AS400 and AS500. So if you look at the routing table of AS400, for the prefix 180.10/16, what is my AS path? Meaning, what are the list of autonomous systems that I need to traverse to get to the network that is originating this prefix? In this case, that is AS100, right? So for 180.10, it tells me that I need to jump to 300, then 200, then 100. So that's essentially, from here, your packet will be passed through to AS300, then AS200, then AS100, right? Same with 170/16, that is to going to AS200, so that's jumping from AS400 to 300 to 200, right? And same with AS500. So I think it should be clear now. If you think I should explain this more, just let me know using the chat. But essentially, these prefixes that you see here, okay, are learned using the same thing. AS500 received announcements from AS300 that contains that AS path. Now, what do we use the AS path for? Of course, that is for detection, for the proper path, for path selection, and another thing is for loop detection. Okay, but what happens if the example here is only using 2 byte? We're familiar with 2 byte ASNs. It's very simple. What about if we have a mixture of 2 byte and 4 byte ASNs? So in this example, we still have a very similar topology here, but instead of using all of them as 2 bytes, we have 3 that are using 4 bytes. So they're still announcing the same prefixes. 170.10 is being announced now by AS80,000. AS70,000 is now announcing 170.10/16. So let's just say that maybe this is the same networks as the previous slide. However, they changed, meaning maybe they've upgraded their servers, they want to use a 4 byte ASN and like that. So they're now using a different AS number. So how does it look like from AS400 this time around? For 180.10, again, you still have to have from 300 to 80,000 to 70,000. But notice that my routing information here doesn't use 80,000, nor does it use 70,000. It uses a special number, and that number is 23456. So from AS400, because it is still using 2 byte ASN, it doesn't have an ID. It doesn't understand 4 byte ASNs. So how does it look like? Then you see just a lot of 23456 values in his AS path. Okay, so from 400, I'll jump to 300. I'll jump to here, but I don't really know that it's 80,000. I just know that it's 23456, and same with the others. Okay, so that is the only difference. However, okay, it is still going to be reachable, and I will explain to you why. But essentially, even if you see a lot of 23456 there, okay, when the routers act on the received packets and forwards that, it still knows how to reach to a 4 byte to a network that is using 4 byte ASN, right? Now, I think one of the reasons why you would want to upgrade to 4-byte ASN is exactly this. Okay, if you're still running 2-byte ASNs now, there is no problem. It can communicate with 4-byte ASNs, no problem at all. But the only thing is, when you look at your routing table and you see a lot of values that says 23456, you have no idea. So if you're doing a troubleshooting perhaps, then you can get stuck into looking at, hey, where is the actual path? How do I know which ones to contact? Because I'm only seeing, okay, a generic AS number 23456 here. Okay, so that's one of the reasons why you would pretty much want to upgrade and support 4-byte ASNs. Otherwise, as I've said, they can, okay, they have compatibility with each other. But alright, now here we are going to explain how your routers can still jump from 4-byte to 2-byte and then to 4-byte without having any issues. Right, so just look at it like this. So from 300 or maybe from here is 90,000, it goes to the older AS number, AS300, and goes to a new AS number, AS80,000. So let's look at it from this perspective. You have a 32-bit AS realm, okay? It's using 32-bit AS numbers, but then it has peering with someone that is using only 16-bit. And then this someone also is peering with another network that is now using the new AS number. So how do we go about transition? Okay, remember from here you only see a lot of 23456. But how does it work from the router point of view? It's simply like this. There is a translation going on from 16-bit to 32 bits, right? Because from here, your 32-bit AS number will be represented and translated into a 16-bit AS number, which is 23456, and that will show up in the AS path of this older network. Okay, basically, it will translate all 32 bits AS number, okay, from here. This router will translate that into 23456. So from this center network, it only sees this value. Okay? But going to this side, once it is now received by another 32-bit AS number, okay, then it will get the 32-bit equivalent of that. How do you do that? We have attributes, and attributes are properties of your routes. One of the main attributes is, of course, AS path, which lists down all these list of autonomous system numbers that needs to be traversed or hopped into. In 32-bit ASN, we are introducing another attribute, and it's called a new AS path attribute. This will contain the values of all the AS numbers, 32-bit AS numbers, and it's kept still while it is being transferred, okay, or being announced to the 16-bit realm. Okay, it's an optional transitive attribute, meaning that although this 16-bit AS number doesn't understand, this network doesn't understand 32 bits, it doesn't understand the content of the new AS path attribute, it will still be forwarded, and therefore that attribute will eventually reach another 32-bit realm, and he is now able to read through the new AS path value. Okay, so let's just look at a more concrete example so you'll understand that even better. See here, we have two 32-bit ASNs and then going into two older ones using 16 bits and then jump into another new ASN. Okay, so how do we go about that? We have 131072, your AS path will be like that. Your AS path attribute contains 131072 because it's passed through, okay, a new, another AS that is using 4-byte ASNs, right? So it's okay, it's passed as 131072, but the moment that it will be passed through the older ones, okay, my AS path attribute will now contain 23456 only. Notice that here. When actually it should be 131.0.7.2.74, and that should be 4, 131.0.7.2, which is from here going to be passed here, and 131.7.4 when it's passed there. So think of it as a stack. I'm stacking the ASNs that I need to traverse. So 131.0.7.2, on top of that, put 131.0.7.4. So my new AS path attribute contains this, which is the correct path going to 131.0.7.2, right? But since we're dealing with an older version here, the AS path attributes now contains only 2, 3, 4, 5, 6 values for both of these autonomous system numbers. Now, so when it's received by this 1221 ASN, then it is read as 2, 3, 4, 5, 6, and then it will be passed through, of course. It will add its own AS number to the stack. So that's 1221, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6. However, notice that your new AS path attribute still has the same values as before. You don't stack up 1221 there because it's only for 2 bytes. Okay, it's not using 4-byte ASN. Then it goes to 4637. So again, you stack up. You add 4637 on top of 1221. So it looks something like this when it's received by the last network here. So you have 4637. So your AS path will be, for a prefix receive here, the AS path is 4637, 1221, 23456, 23456. Right? So what we essentially see here. But I can, this router here understands 4-byte. So I need to now convert this back, these 2, 2, 3, 4, 5, 6 values, I need to now convert that back into its original AS number, which is contained in your new AS path attribute. Okay? Since you have 2 here, and then you have 2 in the stack here as well, okay, you can pretty much map it up. Okay, you know that the first 2, 3, 4, 5, 6 is for this. The next 2, 3, 4, 5, 6 is for 131.0.7.2. Okay, so that will be mapped there, and your final AS path will be 4637, 1221, 131.0.7.4, 131.0.7.2. Okay, so that's essentially how it is. It's quite simple when you look at it at this level. Okay, but a lot of people get confused at why or how do we use 2, 3, 4, 5, 6 values. Okay, how does the router still understand that? And the reason is because we have another attribute, okay, that is introduced only to contain the values of your 4-byte AS numbers. All right, but the question is, does our network, our BGP, our routing process, does it ever get confused? Remember, we have a lot of 2, 3, 4, 5, 6 values. So let's just say from this network, so network 1221 using 2-byte, okay, what happens if we have 2 upstreams, 2 networks, okay, both of them are using 4-byte? I think this will answer your question, Taylor. Both of them are using 4-byte, but what happens? How does the prefix looks like in my routing table? So see here, you have 10.0.1.0/24, which is coming from 131.0.7.2. You have 10.0.2/24 coming from 131.0.7.6. So for this first one, your path will essentially be 131.0.7.4, 131.0.7.2. But you see that as a series of 2, 3, 4, 5, 6, right? 2, 3, 4, 5, 6, 2, 3, 4, 5, 6. The next one is, for this, 10.0.2, again, it shows up as 2, 3, 4, 5, 6. Now the question is, how do I know? Like, where do I submit my, let's say if I receive a packet, a traffic that is going to one of these, how do I know where it should go? It says here that forwarded to 2, 3, 4, 5, 6, but how do I know? Okay, now this is never a problem. Okay, the reason it looks like a problem is because we're only looking at one attribute. We're only looking at the AS path, or basically the AS path attribute. But as BGP, the routing entries there have other attributes, and one of that is next hop. Next hop is an attribute that tells my router which interface I'm going to forward the packet. In this case, for 10.0.1, it will go through my next hop is via interface A. For packets that are going to 10.0.2/24, it will be going via interface B. So that is not a problem. It's a normal, it's a standard BGP process, standard BGP behavior. So your router will never get confused. Okay, so that's it. It's pretty easy if you look at it this way. Any questions? All right. So yep, we've looked at this. This is the new AS path attribute that we've just discussed. Now it's a transitive optional attribute, meaning that your router doesn't essentially have to understand it, but even if it doesn't, that property has to be forwarded. Okay, if you're announcing these route prefix to other networks, it has to be passed as well. That's why routers that are running only 2 bytes can still pass that value on until it reaches, let's say, another router, another network that now understands the 32-bit domain. Okay, so that's a should, not a must, meaning that it doesn't necessarily have to be supported, but it has to be forwarded. All right. Another thing here is the new aggregator attribute, a transitive optional attribute also added in these update messages that contains the aggregated value and the AS path that are announcing these aggregate values. So it's just pretty much similar to the new AS path attribute, but it's another one that is just reintroduced specifically to support 4-byte AS numbers. So we've looked at AS23456. Okay, so just don't get confused if you see a lot of 23456 values in your routing table. Okay, it's not a mistake. It's normal. It's not an error. Okay, it is there because it's a handler. Okay, it's a handler of the 32-bit AS numbers in a 16-bit domain. All right. Okay, this is just an example, an actual router that contains prefixes, in this case 2001/32. This is IPv6. Okay, you have these other metrics there, other values, other attributes such as your next hop, metric, local preferences, weight. But our main concern is, of course, the path value, which is our AS path. So if you see here that for this 2001/32, your AS path will be via 23456, 38610, 6939. So you can see it very clearly that there is, okay, one hop. Okay, there is a hop here that is using a 32-bit AS number. All right, so that's really just what I want you to look at. All right, so as I've said, it's a pretty easy, pretty straightforward class that discusses essentially just a minor part of the entire AS number and also part of BGP. But if you want to learn more about AS numbers, I have another class after this that discusses AS numbers, right? However, if you don't have any more questions, we finish up quite early. But I would just like to write the link to the survey. If you can please fill this in, I'd be very glad for that. So that's 2013. What's the date today? 04/26. Oops. 03/26. Look. Right. So yeah, here's the link to the survey. The handouts will be available after you've completed the survey. If you have any questions, you can write it here or, okay. Side question, does ePnic provide advice support for service providers relating to network design? Yes, we do, depending on what type of support you're looking at. We do for the training team, we do something called engineering assistance. So someone can have a look if you have more specific, more customized questions. Someone can have a look at your network and yeah, help you out with it. Send me an email about it, and I can give you more information. All right, cool. All right, so I guess we will end the class here. Thank you very much, Taylor, for joining me this morning. It might be a bit too early for you, but anyway, thank you very much, and I hope that we can still, you can still join us in our other sessions.